Welcome. We're looking at task 4.2. It's more with the piecewise functions, which are combining different sub-functions here. And this is a context of a bike ride, looking at distance, in this case per hour. This will be the distance, this will be the hour. When are they going the fastest and the slowest? So for that, we want to look at the slope, or in this case, the fastest slope is right here. So this would be 0 to 1 hour. And then that's the fastest because it's the steepest. And then the other one, 10. So from 1 to 2 hours, that would be the slowest, because 10 as a slope has the least change over time. The domain, we can see, goes from 0 to 4 inclusive, interval form. Find f of 2. So you could either look at it here or here. Either way would work. So to do that, f of 2, I'll do the first one. 10 times 2 minus 1 plus 16. So 10 plus 16 is equal to 26. Let's see. What's the total distance? So the total distance, we would look where they are after 4 hours. So what we want to do is we'd say, well, what's f of 4? And that's, I'm going to use the last subfunction here for that. So 12 times 4 minus 3 plus 40, which is 12 plus 40, which is 52. They started at 0, so therefore 52 miles, which is a pretty good ride. Pretty good ride. Sketch a graph. So we're going to use some of this stuff with the point slope. I notice looking at this that at 1, there's a point slope, x minus 1 plus 16. That means there's a point at 116. So I'm going to use that to help me graph it. So 116 might be here. I also notice that at 2, there's a point 226. So for this one, I'm going to go with something here. And I also notice another one at 3. There's going to be a point at 340. Okay, as a point slope. So I'm going to go over here to 3, and I'm going to go up to 40. Okay, so then I've got each of these as different intervals. Did I miss one? The first one, 10. Okay, so I just used those points, those 3 points here. 1426, 226. Do I have 226? I do. And 340, I do. So yeah, starting at the beginning, we got 4 intervals. The steeper one, the steepest one, is right here because of the 16. Let's see. Let's look at a couple others. Average rate of change is a very important concept moving forward in math during the interval. This is almost a calculus type question. So if the interval, the domain is 20 to 50, okay, the average rate of change is the change in y over the change in x. It's the same thing as the slope. Okay, so the change in y over the change in x from 20 to 50. So first we have to figure out at 20, what is the value, or what is the number of miles, and these are miles in minutes. So at 20 minutes, you can see from the point slope, x minus 20 plus 5, there is a 25 value. And then you can see also from point slope at 50 minutes, there is a 11 value. So the change in y here would be 11 minus 5, okay? And that would be over 50 minus 20. Okay, so the average rate of change here should be 6 over 30, which is 1/5. So it's 1/5 of a mile for over a minute. But you can also get it, there's another way you can get it, and that's to go directly to the equation, and you notice that over that interval, the slope, the change, is also equal to 1/5. Okay, which one is the greatest rate of change? So it's really saying which fraction is greater. Well, it's definitely not here. It's definitely not here. So you've got 1/4 and you got 2/7. 1/4 is the same as 2/8, and 2/7. If we compare these two, 2/8 is less than 2/7. So therefore, it's this third interval from 50 to 92.